let's wait for 5 minutes more and then we'll start discussion. So one thing is, I generally had the discussion. I generally in the discussion group, I want everybody to get participate. It doesn't matter it's wrong or right. There is nothing wrong in data structures. Okay, and I want everybody to participate. So whatever we do, I want. Okay, so generally for a problem when we start with any problem solving part, when we are going to discuss it. Because what I believe in, the discussion brings more knowledge to the table instead of one to one. Okay, so that's how we are gonna do it. I want when we move to the problem solving part also, I want everybody to think about this approach. Okay, so that already I discussed in my generally in my demo classes that whenever a problem is given to you, think about the different solutions about it. Once you do that, your thought process start building up, and that is the most important part here. Okay, it's not about I just give you some problems and solve it out. It's not. Okay, okay. So let's begin our discussion. Sorry, am I audible?
Yes.
Okay. Is desktop is visible to you?
Yeah.
Okay. Hi, Harsh.
Yeah, hi.
So let's begin our discussion. So as usual, let's begin our discussion with this word. Okay, one more thing. I'm very bad with spellings, so please bear with me. Okay, what is data structure? What do you think? What exactly a data structure means?
Settings of data. How we are going to arrange the data.
Okay, arrangement of data.
Organizing data in different files like
Yes.
images and
Okay.
storing data in different.
Okay. So what? Why we? Okay. So data structure. You all are correct. Structuring the data in such a manner. Okay. So we are structuring some data means organizing data or storing in certain formats. Why?
Get the data very easily or very fast. How we arrange the
Okay.
data will get to it.
Retrieve the data. And so how
Okay.
we want to retrieve the data.
Mhm.
Through different ways.
Okay. What, Harsh, why we need to organize the data or structure the data?
So that we can do meaningful things with it, like retrieve it in some sequence.
Mm-hmm. Okay, that's correct. So what happens is we have a lot of data. Okay. Generally, before, see, lot of data, nowadays we heard the name of machine learning and blah blah. They are doing really good job there. But normally, in normal applications also we have to handle a lot of data. So to handle a lot of data, handling means to perform some basic operations. So basic operations like insertion, deletion, or searching in it. These are very, very basic operations we want to do. Now, data, so all the data, let's take a real world example. You have a drawer in a wardrobe in which you put socks. Okay? So every socks come in a pair. What if, so there are two scenarios. In first scenario, you put all the socks in a random order and put it in wardrobe. Now you have to pick it up a pair. What you will do? You go look into it randomly, pick it out, takes time. But instead of that, I nicely paired every socks with the other pair, with the other part of the pair, put it in some clip and rolled it out and put it in a nice manner. And then I will ask you, okay, pick up a pair. Will it take a less time? Yes. The same thing happens with the data also. What happens if you have some random collection of data? It will take more time to do this basic operations But if you organize the data in a better manner, in better way, then you can easily find out in a less time. Okay, so that's why we need to organize or structure the data so that the basic operations of insertion, deletion, or searching or anything will be easier for us. Okay, now, sorry. So that's what about the data structure. Now I'm going a bit diverting from the point. We'll discuss today about certain mathematics also, not in depth. Mathematical notations actually, that's not the particular notations, sorry, particular equations or something. Before that, okay, what is a variable? To reach that part, we'll discuss it again. What is a variable?
Something that should hold a value.
Okay. What is variable?
And you can, the value keeps changing.
Okay. Swati, what's a variable?
Variable is something which changes its value.
Okay. You all are correct. But variable is just a name. Variable is nothing, it's just a name given to some specific location. In memory, if you talk about computer world, it's a memory location. You give it a name to that memory location because memory location are hexadecimals where it's very tough to use it in our programming language, in any of the programming language. Okay. So variable is just a name given to a memory location in which some type of data is going to store. Now, any type of data has some characteristic. Any characteristics, like it can have a range, it can be positive, negative, it can be anything. So all these characteristics we define by data types. Okay, so it can have 3-4 characteristics. So every time we are not going to mention that 3-4 characteristics. So that we use a data type. Like int, so data type again, you have int, floats, double. When I say int, it defines a range in it. Okay, and variable is just a name for a memory location, and that type of data is going to be stored. And you all are correct. Variable is unknown. Okay. Data structures. Okay, I'm a bit context switching between 2-3 things. Coming back to data structure. So data structures are very generic in nature. Are very, very generic in nature. What happens is, I don't know whether I have discussed this part in demo or not. Data structures are just concepts. You can implement them through any language. So they are not bound with the language. And this genericity is make them very unique or very, very special or very important. Okay, because they are not bound with any language, they are not bound with any text. So if a person is very good in DS, data structures, then they are not judged by any certain parameter, how much Java you know, how much C++ you know, it's okay. So for example, right now I'm working in a project with C. I'm using certain C. We already, so most of us are already professionals. So we know that most of the code is legacy. And sometimes now legacy code is transformed into some certain different code, like mainframes. So earlier the banking domain are working on mainframes. Now they are converting to Java. So professionals have a mainframe experience of like 4 to 5 years. Now all the algorithms which are running, so all the codes which are written in mainframes need to be converted into Java. So for that conversion, some genericity is needed. Okay, that's why the data structures itself comes into your design part. When you design a solution or think about a solution of any particular problem, your thinking just not stop at the design level itself, like the architecture. Okay, I'm going to use certain tag and all this. No, deep down also you have to think about it, because later on if you are going to switch between any two or change, migrate from here to there, nothing should break. Okay, So the data structure, we always, all the things we try to keep it generic. So whenever we think of a solution and problem in, think of a solution for a problem in DS, we keep genericity in mind. We don't use anything which is specific to language. Okay. So for example, I'm trying to solve one problem in DS and I take an advantage of Java language. Is it good? No. What if it converted to C? It will break. Okay. We try to keep it generic. When we try to keep it generic, we need to discuss over the parameters which is very generic in nature. That also need to be generic. They also doesn't. We'll look into more further. Okay. So data types are two. Data type itself divided in two categories. One is user defined and one is system defined. User defined is something you called as structures, classes, okay, which combine different type of primitive data types into a bundle and you can use it. Primitive data types are your integer, float, double, all these are the primitive. Okay. Now, there are two types of data structures. One we called as a linear data structure, another we called as a non-linear data structures. What is linear data structures? Okay.
Sequential. Linked.
Okay. So you have data. Now what is a linear data structure? You are organizing in a sequential manner?
Yeah.
Okay. What is non-linear?
Tree.
Forget about tree. We don't know the word tree right now.
One to the other.
Okay, let's say there is no relation. Okay. See, linear and non-linear, it's not depends on how you are storing. It always depends on how you are accessing. Okay. For example, if I arrange one by one everything, let's say you have 10 balls, your number from 1, 2, 3, 4, 5, 6, 7, 8, 10. You want to retrieve the fifth ball, but they are in a pipe. How you will do? You have to take out first 4 balls and then you will take the fifth one out. This is something we call as a linear. Means to access an element, you have to go through all the other elements before that and then only you can access sequentially. So, non-linear, suppose they are not in pipe, it is visible to you. Or putting it in a box, you can directly see fifth, you can take it out. That is non-linear. So always it's about the access. It's not depends on the storage. Okay. So if you access sequentially, then it's called as a linear data structure, and if you access and randomly or non-linear fashion, it's called non-linear data structure. Okay. Next is, are we clear so far? Are we good? Are we good? Harsh, Swati, Mona, are we good?
Yeah.
Yeah. Yes.
Mona, am I audible to you? Okay, I got it. Okay, awesome. Next word is algorithm. What do you think is algorithm is?
Sequence of steps.
Yes, sequence of steps to be followed. Anybody else? Anything, see, that's what in the starting of the discussion I told you. Anything comes to your mind, speak out. It's nothing wrong or right. What's
The
algorithm?
way you provide solution to a
Okay.
particular
Correct. So, correct. Algorithms are step-by-step, sequential solution to a problem or sequential steps to be followed to solve a problem. Now, algorithm can be anything, like preparing a tea. So, what we do for preparing a tea is we take out a pan, put a water, milk, all the stuff. So, step by step we follow. So, when I say sequential step means one step, then the second, then the third. You can't jump into the third step. You can't, without putting pen, you can't put the milk. Okay. That's why the algorithms are step by step, sequential, sequential step-by-step process to solve a problem. Okay. Now, when I told you about genericity, the algorithms are also need to be generic in nature. Okay. So, for example, again, preparing a tea. Take a pan, water, milk, tea powder, heat it some degree, filter it out, and put tea is prepared. This is very generic. We didn't talk it about I want a Tata tea only or Nandini milk only. Okay. When I talk about a very specific, then it will be a problem. Because let's say, again, same example. If I give my algorithm, if you ask me, okay, give me an algorithm for preparing a tea. And if I give you the algorithm like, okay, take a Prestige fry pan, put a Bisleri water, put a Nandini milk, and then put a Tata tea powder and flame of Indian gas. It is too much specific. You don't have that stuff. Let's say you have 4 out of 5, but what about the fifth one? It will break. So the algorithm itself need to be very generic in nature. So what I will give you, okay, take any pan, take any water, like this. Okay, that's why I talked about the genericity. That's the algorithm. Now, is it sometimes what happens, not sometimes, most of the times, what happens is for any particular problem or for any particular situation, we have 2 or 3 ways to solve it. Okay. For example, a person wants to go from city A to city B. He can go through bus, he can go through flight, he can go through train. Okay. Which one is better?
So many.
Which one is better?
Depends on
What depends?
The situation, how fast he wants to reach.
Okay. So when a person wants to go from A to B, we have to, when I ask, okay, there are 3 modes of transportation by bus, train or flight. So all these 3 are 3 different algorithms to achieve the end goal. Okay. So for the same problem, there are 3 ways to solve it. Now we need certain parameters to judge which one is better. Okay. So let's say my parameter is cost. So when I say my parameter is cost, then bus will be the cheapest one. Okay. But when my parameter changes, my parameter becomes time, then flight will be the bestest. Okay. So this exactly what happens with the data structures also. In certain situation, you have 2-3 approaches. Among the 2-3 approaches, you have to decide which one are good, which one are not, which one are, see, all are good. Then only we define them as an algorithm when they're working. But among them, which one is the best suitable for us, best suitable for the conditions? It's going to be there. Practical example. Okay, today only I discuss this. Suppose you have a fact. Okay, practical example. I'm going into technical. You have one producer, you have one consumer. Producer produce something, consumer consume them. How you can correlate both of them? You have a producer, you have a consumer. How you correlate? Means whatever producer produce, how you will send it to consumer? How will consumer will take it? There are 2-3 ways again. When producer produces something, it can directly send it to the consumer to use. Either when the consumer can also ask the producer or continuously checking with the producer that if it is available with you, please give it me, I will use it. Or you can put anything you can do. Or you can put a queue between it. Okay. You can, whatever the producer is producing, put it in a queue. So client doesn't have to check, a consumer doesn't have to check with the producer. He can check directly in the queue, whether there is something in the queue or not. So I mean, this is 2-3 solutions for the same problem. But which one is best depends on the situation. So situations are very different. Okay. Now, this is about the algorithm. So in data structures also, for every problem we will have 2-3 problems. For every problem we will have 2-3 solutions. So we have to decide on certain parameters which also need to be generic in nature. So parameter also need to be generic in nature. Okay. on which we can decide that which algorithm is better. What do you think the parameter we can choose? In computer world, let's say 2-3 algorithms you have, then which parameter do you think? Okay. We didn't use word complexity so far. Okay. Can't number of lines of code can be a parameter? Can't the execution time? Execution time means a particular piece of code, how much time does it take to run is called the execution time. Can't it be the parameter? Okay. So there can be many parameters. Okay. But they are not generic in nature. As I told, to maintain the genericity in data structure, we need the parameter also need to be generic. Okay. So if I take line of codes as one of the parameter, is it generic? For example, I have to do certain algorithm, do A plus B. In Java, it's like 4 line of code. In C, it's like 6 line of code. In Python, it is 1 line of code. Both are doing the same thing. Well, all are doing the same thing, but they are more specific to the language. Python is taking very less number of codes, but the algorithm remains same. This is not good. It is becoming specific. Same with the execution. Right now, you are running a piece of code on a Intel processor. It will be a bit fast. It will give you, let's say, 10 millisecond as an execution time. But you run the same piece of code on AMD processor, it will give some different, or the compiler difference will be there. So the execution time also will not be a good parameter. So platform is also now. So there in computer world, we bother about two things very much. One is CPU cycles. Another one is your space. So when I say space, it could be main memory, secondary memory, any memory. Both are very expensive, and this is the most importantly we want to think about. Okay, now the running time. Okay, so a space, the CPU cycle we called as a running time. Okay, now these two parameters are used to do the analysis of algorithm, and they are generic in nature. Now we are going to discuss how they become generic in nature. So we decide on this part. To do the analysis of algorithm, we need running time and the space. Okay. So running time means for a particular input, how much time it generally, how much CPU cycle it generally take to run. Am I good so far? Harsh, Mona, Swati, Anshuman?
Yeah.
Yes.
Okay, awesome. Now, okay. Let's say you have an algorithm, any algorithm, XYZ. You give an input of 10. It takes 10 milliseconds. When you increase your input size from 10 to 100, how much time will it going to take? For 10 input size, it took 10 milliseconds. Now I increase my input size from 10 to 100. How much time it going to take?
10 times around.
Yes?
10 times.
Okay. I'm asking, you have an algorithm. You are giving some input to the algorithm. You give an input of 10 size. Let's say 10 elements. It takes 10 milliseconds. If I increase the input size from 10 to 100, how much time will it take to complete? No.
Depends on the time complexity.
So, okay, it doesn't, you can't say if it is going to take, it depends how your algorithm having a rate of growth. There is one term called rate of growth. Rate of growth means with the increase in input size, by which rate your time is getting increased in your algorithm. Okay, it might be possible that for 10 input size it take 10 milliseconds. For 100 also it will take 10. Okay, it is also possible, and it is also possible that for 10 it takes 10, for 100 it takes 100. That is linear. But it is also possible that for 100 it have taken 10 to the power 4. That is quadratic. Okay, when you give 1 you take 1, when you do 2 it will take 4. Okay, that is something quadratic in nature. So this term is called rate of growth. So rate of growth means by what rate your algorithm is taking time with the increase in the input size. It can be linear, it can be constant, it can be quadratic, it can be cubic, logarithmic also. Okay, so this is we called as a rate of growth. So rate of growth are generally like this. I'm just writing it a type. One is constant. Log n is your logarithmic. N is linear, and log n is linear logarithmic, and square is quadratic, and cube is cubic, and 2 to the power n is exponential. So one is constant, logarithmic, linear logarithmic, quadratic, cubic, and exponential. Okay. Now, this very interesting part when we relate rate of growth with the algorithms. Again, let's take a. Again, we want to be more generic. Let's say rate of growth can be expressed in some form of equations. Equations are used where you have unknown quantities. What is unknown in data structure? No. What is unknown in data structure? Unknown means what thing is unknown in data structure. Your input size is unknown. Okay. In data structure, the input size, we always keep in mind that it can be anything. It is very big. Okay. Like we don't rely on millions also, billions also. We always keep in mind that it can be infinite. Infinity is not an entity, so it can be very huge, which is unknown to us. So we always keep in mind that the input size can be very, very unknown quantity. We can't define it. So we always use it in our calculation to judge the parameters. Okay. So unknown is the input size. So it can be very huge. Everything. That's about. Now, rate of growth, again, why we want n to be unknown is because when you define a certain quantity, let's say your algorithm is working for an input of million, what if it is become billion? There's a chances of getting break, and it happens, literally it happens. Do you know YouTube? I have given this example to few of the people, but I'm sharing with the rest of the people. Do you know YouTube? YouTube is a video sharing platform. They have a feature called views. View. How many number of time a particular video has been watched. 3 years, 4 years, 5 years back, there's one video coming called Gangan Style. Okay. No issues. So when that video published, the view count becomes so huge that it starts showing into negative. What happens is they predicted that they have to handle the view count in millions or billions, and it go beyond that. It got crashed. And it's just view. What about it is something very crucial. For example, banking domain. Right now, today, you wrote an algorithm to find out the top 10 banking transactions among millions. So among millions, you have to find the top 10. But after some time, it becomes billion. Your bank becomes so popular. Okay, you never thought. Everything could break. Okay, that's why to keep it generic, to keep the parameter generic, to judge the algorithms in generic nature, we keep in mind that an input size can be anything. That's why it becomes unknown. So rate of growth which we are going to measure is we are going to measure in terms of input size only. So when we have the unknowns, then we have the equations, mathematical equations. The equations are created with the help of variables which are again unknown in nature. Okay? Okay. So before we came, we discussed a few things like what is data structure, algorithm and all. Right now we are discussing on rate of growth. So rate of growth is something in an algorithm. When you give some input, certain time it takes. But when you increase the input, the time will also get increased. But at what rate it got increased, it depends. Okay. So that's what we are discussing right now. Now, let's take an example, real life example. Suppose you are going to the market to buy a car. And your wife say, okay, when you are going to buy a car, let's buy a bicycle also. You go and you are in the midway, you are going in the market. You have one of your friend met you and ask where you are going. What will be the answer? General answer.
Well, I could
To buy a car. Generally, we say the bigger things. Okay, generally we say the bigger things. So let's say it's not a bicycle, it's a grocery. Okay, if I talk in terms of rate of growth, comparison, relative comparison. So when you go to a market to buy a car and buy a grocery, generally if somebody asks you where you are going, what the purpose, then you are generally say we are going to buy the car or something. Okay, that happens with the rate of growth also. So if a rate of growth is represents like this, n to the power 4 plus n square plus 1, this can be a rate of growth because n is the input size here which is unknown. So we want the rate of growth to be the biggest value. So the biggest value here is n is to 4. So we approximate to n is to 4 actually. Okay, we are making the things very general. Okay. Also, if I have something like this, 100 and no, 100, if I have something like this, n plus log n plus this value. What will be the rate of growth here? N. Because anything, any known value in data structure is constant, and constant is 1. Okay. Even if I have the value like this, 100 n square, I will write it like it as a n square. So this is about the rate of growth. What we did is we strip down all the approximations here and there. We say, okay, approximately it will take. How to margin that approximate, we will see it later. Okay. So this is about the rate of growth. Now, okay. Okay. Let's talk about the type of input. Are we good till rate of growth? Rate of growth is good? Harsh?
Yeah.
Anshuman? Cool.
Yeah.
Okay. Now, what happens with algorithm is one more thing. The behavior of input also changes the execution and the running time of an algorithm. Okay. Let's take a practical example. You have sorting algorithms with you. Let's say you have one sorting algorithm, anyone. You give 10 elements to it, okay, in sorted order. It will take some time. You give 10 elements again, but in random order. It will take certain time, and you give 10 elements again to it in descending order. It will take another time. So I will write it down. It will be more clear. Let's say you have a sorting algorithm, then the input I input first, you give like this 1 2 3 4 4 5 6 7 8 9 and 10. Second input you give like this 2 4 1 5 7 8 7 6 10. What I left 3 and 5 or 5. Any number left here? 9. Okay. And the third input you give like this 10 9 8 7 6 5 4 3 2 and 1. Okay. Now it will first question. Will all three will take the same time?
No.
No. Why?
No, what algorithm is going to use? Same algorithm is going to apply.
Same also.
So
Let's say we have a sorting algorithm called XYZ. Same XYZ we are going to apply.
some of the data is in sort of you get the data what the algorithm is written on it. You get a frequent. Some data is random. You check edit all the data and then take it from depending on if you do the reverse thing.
Okay. So all are agree that it will take different time. I also agree that it will take different time. Let's say even E2 and E3. So see, the behavior of input changes your execution time here for an algorithm. Okay, so this behavior we also categorize as a best case, worst case, and average case. So this is about the input characteristic, whatever the input you are giving. So here I have my input size remains same 10 10 10 only, but you can see that already sorted input will give you the less time. Average will give a bit high time, and the descending one give you the worst, the most time. Okay. This characteristic we define as best case, worst case, and average case. So we called an input as a favorable input, unfavorable input, and any other input which is favorable or unfavorable. So favorable means the best case. So which is the favorable here?
Depends on the algorithm.
Sorting algorithm.
Also,
All the sorting algorithm does only one thing, sort. That's it. So the favorable one is the input one. Okay, so that is we called as a best case. Okay, second one is average. Any random order is the average. Third one is the worst. Okay,
but if you took a quick sort or merge sort, then first case will be first case.
we'll discuss later that. Because right now I have keeping in mind that nobody heard the name of best quick sort and merge sort.
Okay.
So, and we'll discuss after the because it is pretty much same for that also. This is the worst thing. So, depends on how your input is, whether it's favorable to the algo or unfavorable to the algo. We define it as a best case, worst case, and average case. So, best means it takes the least time, worst means it takes the most time, and whatever the spectrum between the best and least and the most comes under the average. Okay. Here also, see that rate of growth depends on the size of the input. This is the characteristic of the input. Okay. Here also, when you increase the size in the favorable input condition, your rate of growth will be changed. Okay. It means that for each best case, average case, and worst case, they have their own rate of growth. Okay. So rate of growth does not remain same. It is different for different characteristics. Okay. So for example, it might take some rate of growth as R1, might take some rate of growth as R2, and it takes some rate of growth as R3. Okay. Do you convince with me? Harsh, Swati? So, see, there is a very fine layer between the input size and the input characteristics. People generally misunderstood that part. Input characteristic defines how your input are favorable, unfavorable to the given algorithm. Okay. For example, we take an algorithm of making a tea. What if I already have given a tea bag? I just have to take a boiled water or a powder it. Ready-made tea if I have given. That is something favorable. And all the steps we have to follow, that is unfavorable. Okay. But number of tea which you have to make, the rate, the time, let's say, when you have given tea bags, if you have to make 10 cups of tea, then some rate will be followed. So 20 cup of tea with the same approach, some time will follow. And the rate for when you prepare with the complete process flow, that rate will be different. So for a given algorithm, for a best case, worst case, and average case, the rate of growth are different. Okay? Clear? Harsh, Anshuman, is it clear?
Yes.
Yes.
Okay. Now, so it might be possible that for the same algorithm, not this, any hypothetical algorithm, it might be possible that the worst case can be this and the best case can be this. Okay, this is. Now, see, as I told, algorithms are defined very in the early stages. Okay, to solve any problem. We want to make margins in it. For example, right now you decide an algorithm. You say, okay, for the very unfavorable input, it will take a time of 100 milliseconds. I agree. But first thing, we are humans. We always prepare for the worst part. Again, I want to take a margin. Okay, I know that 100 is a threshold for my algorithm. Okay, but I still want to take a margin because anything can happen and we don't want an algorithm to break. That margins are defined using some mathematical notations we call as asymptotic notations. Okay. So asymptotic notations are used to define, in layman terms, I can say boundaries over a rate of growth. Okay, because people misunderstood the worst case, best case, and all these things with the asymptotic notations. Okay, both are different. Let's see. So you have three types of asymptotic notations. One is called big O, omega, and theta. What are they? I will tell. Asymptotic notations. Okay. Suppose your function is growing in this way. Okay, this is your rate of growth for a particular algorithm. What the big O notation says, there is another function which put a boundary on this function. Let's say g of n. It says that your f of n, this is the input size. This is the time. It says how the rate of growth increases for any input size, it never ever going to cross this g of n. This notation defines the margin. Again, 100 milliseconds, we decided that in the unfavorable input, it's going to take 100 milliseconds. But we want to put a margin. That margin of 110 milliseconds is put by g of n. Okay, so rate of growth, when we write it like this, so f of n, I can write it like this, n square plus n plus 100. If I apply big of notation on this, so rate of growth will be n square only. Big O notation doesn't do anything else, it just say that there is another function, or there you need to decide a function on which can bound this. It's just a notation. Okay, so this notation is given to realize you that we need a margin. Okay, that's why it is called as big O notation. Okay. Similarly, we have omega notation and theta notation. Can I clear this?
Hello, one doubt.
Yes.
So this is like best case or worst case? I mean,
See, I'm not talking about any best case, worst case. I'm talking about rate of growth. So every worst case, best case have their own rate of growth.
okay.
So big O notation can be applied to any rate of growth. It means that big O notation can be applied to best case, worst case, and average case.
Okay. So rate of growth is big O notation, is it?
Yes. Notations are to say that you need to have a margin here. Okay, that's why we are using notations.
Hello.
Yes.
I also have a doubt. Like you said that Gn is the boundary condition of f of n, that in no case the function will extend Gn. But
Yes.
then how come for n square it is the boundary is n square only? It should be like n cube or n4, right?
See, I am not defining any function here. See, I just said that you need to have a bounded function to give you the margin. I don't calculated that margin yet. Okay. I just told you that if I applied a big O notation, it means that whenever you are deciding on some hardware parameters, anything, you have to keep a margin. So it is like that. Your algo, any algo, is taking 100 milliseconds. Okay. I will put big O on 100 milliseconds, so it will tell you that you need to have a upper margin, upper boundary on this algo. It can be anything. It can be 110. It can be 111 also. It can be 115. It depends on you. Okay. And it depends person to person. Okay. What happens is, why we need this? When you have an algo, any algorithm design, you need to decide on the hardware parameters also. Okay. So let's say you have an algo. You know that in the worst case, it can run for 100 milliseconds. Now you have to decide on a platform. It's not I have designed the algorithm, my work is done. I told you that it will, in the worst case, it will go for the 100 milliseconds. I gave that requirement to 2-3 person. Okay. They have to decide on the platform requirements. Platform requirement means the platform on which it is going to run. Okay. Now, when I put big O notation on 100, it means that you have to decide a margin. It depends up to you how much margin you can put. You can put a margin of 10, you can put a margin of 15, margin of 20 as well. It depends on you how much margin you want to put in. Okay, that's why we don't give the margin itself. Let's say I give the margin itself as 110. But what if you have the margin of 15 also? But if I restrict it, it will be more specific. As I said earlier also, we don't want to be specific. We want to be generic. That's why I will put big O notation on 100, and it's up to you. You have to decide how much margin you can have. I just told you, you need to have a margin. It's up to you how much margin you can have. Okay. So that's why we just put the notation to tell the other person that you need to have a margin instead of saying that exact margin you need to have.
Margin will decide the boundary.
Yes, margin will decide the boundary. Means anything happen, it will not go beyond that limit. Okay, that what means by these notations. That's why we generally called it as a notation only. Otherwise, it becomes a value. Okay. Are we clear so far? So Pratik,
Yes.
have I answered your query?
Yes. Yeah.
Okay. Now let's see the another one. Because I will tell you, okay, after this discussion, I will tell you. So big O notation, or sorry, omega notation. This is, it will put a lower boundary on your f of n. See, we need both upper boundary also, lower boundary also. Okay, why? When, let's say, your algorithm runs fastest of 10 milliseconds, but you can, when it runs very fast, the CPU cycles and everything is very fast. It can crash a CPU also when some algorithm runs very fast. So you have to put a margin there also. Okay, that okay, right now it is running for 10 milliseconds, but it might be possible that it can run also for the 8 milliseconds also. So that is again that need to be handled. So that is represented by omega notation. Okay, again the same thing, you put a omega of n square. It will tell that it may become faster on this. So you need to have a boundary here also. All the notation we apply to the rate of growth. It doesn't relate with the best case, worst case, and average case, because person or some reference book says big O notation is a worst case, omega notation is a no. They are not the best case, worst case, or anything. They are just the notation which are applied to the rate of growth. Okay, to represent the boundaries or the margins. Okay. Similarly, we have a theta notation, which puts boundary on your average. On a means, let's say it puts a boundary like this. It says, on an average, you can be in this boundary. Okay. So let's say on an average, I can say sometimes we need that also. Fastest possibility and the worst case possibility happens once in a day, or once in a year, once in a decade. But generally, we happens on the average case also. So in averagely, how much I need to bound it. So let's say general transaction, I say, okay, in generally I have 10 milliseconds. So what he do? Okay, he can put different thresholds. Okay, so threshold levels can be different. So one threshold level, he can put near to 8 and another to 12. Okay, on an average, you can run between 8 and 12. But putting 6 and putting 15 can be your omega and can be your big O. Okay, so for example, my rate of growth is 10. So putting 8 and putting 12 is your theta. And putting 6 and putting 15, this is become your big O. And this is becomes your theta. Okay. And all this is required mostly for the platform requirements. Also, it happens now the migrations are happening, as we talked earlier, that some of the technologies are like mainframes are migrated into Java. So all the algorithms which is written in mainframe need to be written in Java. So we need to know how much margin how much platform requirement we need to have. Okay, because see, Java is a language, but it also needs a requirements. Okay, when you deploy any of your applications, the deployment machine had certain requirements only, then you can go beyond. Okay, so these are just the margins. Theta is, see,
Because
take this example.
in this example,
This is just a closer boundary. On an average, you can
how
touch
we
this.
decide the closer boundary?
You don't need to decide. You just give like this. Theta of 10. The other person will decide how much they can on an average. See, what happens when you decide on a machine is there are two parts. How can it break? Okay, but on an average also, say, let's say a RAM. You have 2 GB of RAM. In normal computation, on an average, you use 1 GB of RAM. But in the worst case, it will go beyond 2 GB. Touch 2 GB, not beyond. On an average, a RAM is a single disk. It needs to perform consistently. Okay. So there are two sliders, two sockets. So the one socket is for the more of an average and one is for the extended. So the average need to be more performant as compared to the extended to handle the average. This is a slicing. When you apply the theta, it tells them that, okay, on an average case, we have to put a small boundary where the performance need to be more strong, because that is on a daily basis we are going to touch. But the last boundary here and there, we need to put it how much we need to extend. That's it.
That means the person's
Yes.
decide that,
Yes.
boundary.
So either we are the platform of anybody. Persons means anybody, anything. But what happens in algorithms? We want to put the worst of the worst margins, the worst case. That's why everything is, we put it in a big O notation. Okay, we put it in big O notation.
So we will just you know that we are going to give a rate of growth. Okay.
This is everything for rate of growth.
Rate of growth. But in big organizations, you don't, there we have to depend margin, then we get the boundary. Okay. But what about this data you have decided? This is the max.
These are first thing. These are just the notations. You don't have to decide on anything. You have a rate of growth. You have to give a rate of growth with some notation. Using that notation, another person will decide.
Margin.
Margins and every person will decide. So, for example, I told you that my algorithm rate of growth is n or 100 or 10 with big O notation. So you know that you have to put a boundary over it. Okay.
So you put the full boundary, right? One for
No.
upper.
This for theta, this two boundaries. This is one boundary. This is one boundary. Okay, I will change the pen color. This is theta. I made a mistake. Sorry. This is omega. This is omega. These two are theta. This is big O. Okay. This is now. If I talk, this is all about the genericity. Now, this is what we call as a complexity. So normally people ask the complexity for the worst case, and that too in the big O notation, because that is the last boundary. Okay. Now, generally people focus only on big O notation, because as a human we generally wants to prepare it for the worst of the worst things. That's why. Okay. Let's take a break for 5 minutes. Then did I forget something? You got the difference between the best case, average case, and the rate of growth. Okay. Okay. Let's take a break for 5 minutes, 10 minutes, and then we will come back and discuss, do some practice on the coding practical purpose. Okay. Okay. How? So visualization of complexity is a bit different to different. Sometimes people just look at the code and see, okay, this will be the complexity, but that is not. So I have defined the complexity in my own terms. So I'll explain that. So we'll do the practice and all this stuff after the quick break. Okay. If you want to go out, water and everything, there's a tea upstairs. Guys who are online, we are taking a break for 5 to 10 minutes. We'll back by 1:40. So Pratik, you have any doubt? Hello. Am I audible, guys?
Yeah.
Okay.
Yeah,
Take a
you can hear.
Let's take a break on 1:40. We will continue the discussion.
Yes, sir.
5 people are there.
No, 5 people.
Okay. So this two things like running time and the space, we call them as this parameter we call them as the complexities. Complexity is nothing, there's a name given to the parameters on which we judge the different problems. Now, as we decided, there are two type of complexities. One is running time and one is your space complexities. The priority is given to the running time, okay, and then the space. So whenever the situation comes where we have to deal off between the running time and space, we will give the preference to the running time. Okay. And again, it depends on the situation where we have what the different situation is. So, one more important thing. Always, the rate of growth applies to running time only. As I told, the definition itself says by what time your running time is increasing on the increasing of the input size. So it's completely depends on the running time. So big O notation, whatever the notation is, it applies to your time complexity, not on your space complexity. But some of the references book wrongly applies notations on space complexity. One more thing. In space complexity, n and 2n matters. Okay? So space complexity, if you have taken a size of n and you have taken a size of 2n, that actually matters. Okay? But in your running time complexity, n and 2n are same thing. Okay. So, guys who are online, are you good?
Yeah.
Okay. So time complexity are defined as number of time each element processed into number of elements. These are defined as a time complexity. Okay, and space we will discuss more when we do the problem solving. So let's do some practice. Let's say we have a piece of code. This is a simple piece of code where you have a for loop. You are doing something, anything you are doing, okay, and then you have to tell me what will be the complexity of this. Why?
Because the loop is moving for n times, so it will take.
Okay.
And each element will give reverse.
Okay. Everybody agree with this? Okay. So first half, I don't agree. I don't never agree that if loop is going till end, no. Yes. In something, whatever you are doing is always a constant time. Okay. Any number of steps, 1,000, 100, everything is a constant because a certain step will take certain amount of time. So whatever you calculate is always a constant. If you see the loop, every element we are accessing. For every element we are doing something. Okay, so this something is taking a constant time. Let's say C. So for every element we are doing this constant.
Yes.
So So it is n into c or c into n. So when you apply big O notation, or when you first you calculate the rate of growth, it is n. When you apply the big O, it will become order of n. Generally, big O of n, some people say order of n. It's the same thing. What about this?
Space complexity.
We don't know the space complexity.
It is one only. See, space complexity is always calculated in unknown only. So if you have taken an array of size n or something, n spaces if you have taken, where n is unknown, then only you have some space complexity. If you are taking a 1 variable, 2 variable, 10 variable, that are all constant only. Okay, that's it. So space complexity goes with the unknown. So if you have used some n in some space equals to the input size, then we call it as a space complexity. Okay, because input size is itself unknown. So the extra space which is we are going to use is also unknown. That's why then in that case we can say the space complexity is n. Otherwise it is 1 only. Okay, are we clear on why this time complexity is order of n? Number of time each element process into number of elements. So each element is processing only a constant time, and number of elements which we are going through is n. What about this? Okay. Swati, what is the complexity here?
N square.
Why?
Because first loop will take n, and the
Okay.
second, so it will be like n cross constant. So n square.
Okay, correct. But let me define in a better way. I never say because the loop is going. For every element of outside, we are processing n times.
Yes.
Okay. So for every element in outside, we are processing n times, and you have a constant here. So let's say this is constant. This is some n times. This is some n elements. So again, the time complexity, if you calculate c into n, it will be equals to order of n square. Space complexity is 1 only. Okay. Now I will ask specific people to answer me. Calculate your answer, keep it with you. I will ask person to person. What about this? Everybody know the break keyword, I guess. Think about it, I will ask. Okay. Supratik, what is the complexity here?
I think it is n.
Okay. Why?
Yeah, because for each element we are entering into the second loop only one time, and it is exiting out of that loop. So for
Yes.
n time it will be 1 into n.
Yes. So if you see closely, for every element of outside loop, we are entering into the inside, but as soon as we are entering, we are getting out. So entering and getting out is a constant time here. So It is for every element you are having a single term. Okay. So the complexity you are having here is 1 into n, so n only. We go off. Good. What about this? Swati, what is the complexity here?
Um, uh,
Huh? Sorry, I did not able to hear.
is it constant?
Okay. What is the complexity here? Why? The fourth I'm talking about. Okay. So if you look closely, your looping through 10 elements only. So 10 is constant. So whatever defined is always we take it as a constant only. So the time complexity here is constant. Okay. If it is something unknown is given, then we have say okay that the complexity will be different. But if you look closely, we are looping only through 10 elements, or we are going through only 10 elements. Oh, okay. So that's why the complexity here, which we are looking at as one only. And that too, see, in this loops and all, because we are incrementing one by one, that's why we can say we are going through n elements. But it does not happen in every time. Okay, I will tell you, I will give a one case here. Okay, before that, okay, I already gave. Okay. Find out the complexity of this. Complexity. Okay. Harsh, what is the complexity here?
N.
Okay.
And n by 2, n by 4. So separate loops.
Yes.
N only.
So the complexity here is n. Complexity 1 by 2 is also a constant. So n is n. That's why n by 2 is also. The thing is, second loop is going from half of the elements. So still from n by 2 till n you are going. You are not doing like n by 2, n by 4, n by 6. Okay. You are started with, like if you have 100, n is 100, you started with 50. But you are going 51, 52, 53 till rest. Okay. So the complexity here is like this. So you are n by looping through this by n by 2 times, you are going through this by n times. And both are separate. Okay. Both are independent of each other. So the first one is C1 into n, second one is C2 into n by 2. That's why if you take n out, this whole thing is a constant. We can remove it, so it will be order of n only. Okay. And Shubham, what's the complexity here?
N square.
Okay. Mikali, what's the complexity here? Correct. So complexity which we are observing here is n square. So why? Because this is going n times, this is going n times, and the inner loop is also going n times. C1 into n plus C2 into n square. So overall, we are getting an n square complexity. Satvika, is it clear why it's n square? Okay. Well, let's see some other example. What about this? No, anyone of you have iPhone charger? No, phone. Okay. What is the complexity you are observing? Are you sure? See, when we say a complexity of order n, it means that we have went through n elements. n number of elements. Here, if you see closely, we are not going for n elements exactly. See, if I start with 1, next is 2, next is 4 here, next is 8 here, next is 16, and then 32 and 4. So it is, if you look closely, it will more often 2 to the power 0, 2 to the power 1, like that way we are progressing here. Okay. Okay. The thing is, now how to find out how many elements we have went through. Okay. Sometimes you can directly look at it and you can know that what series it is, and you can say, but most of the time we don't. So let's say we check this particular condition when this condition get terminated. For some 2 to the power of some value, this value get terminated. When I become some 2 to the power some value,
Yes.
which becomes greater than n, then it got terminated. So if I write the terminate condition here, it will be like this: 2 to the power k becomes greater than n. Then it got terminated. Just find out the value of k. To find out the value of k, what if I can apply log on both sides? So here will be log of this and log of n. So log of 2 to the power k is equals to the k log 2. K log 2. And log 2 is 1. So value of k is almost approximate equals to log n. So it means that we went through just log n elements, not the complete n elements. Okay, that's why by directly looking into the loop, we can't directly judge that. We have to know how many exact elements we have went through. So here we have went through log n elements. So that's why the time complexity I can write it as order of log n. Okay. Now, tell me about this function. First of all, is it clear?
Yes.
Mitali? Oh, clear. Harsh, is it clear? Swati? Supratik?
Yeah, it's clear.
Yeah, it's clear.
Okay. Then let's do this problem example. Done. Okay, what is the complexity?
Okay.
Deepika? Anybody who's online, what's the complexity here?
It's root n.
Yes, it's root n. See, look closely. Even though I is incrementing 1, 1 only, but if you look closely here, for some value of I square, k square, it will go terminate. So, k is to the power 2 greater than n, it will go terminate. Find the value of k. So, k will be root, square root of n. Okay. Are we good?
Yeah.
Natali, are we good? Harsh, Swati, Mona, is it clear? Why it is the square root of n?
Yes.
Okay. It's clear. Then one more. Try to find out for this.
This is right.
No,
Last time,
ask it reduce.
I'm going to assign.
Okay, so I is starting with 1. So n can be anything, no?
Anything in the last one, I equal to I by 2.
We can do that.
But we cannot increment.
So let's say I is 1.
Yeah.
It will become 1 by 2, 1 by 4, 1 by 8. You can do now. The same way we do I into 2, same way I can do I into 1 by 2.
But there will be no element in that place, no?
Which place?
I mean, suppose you are traversing an array. Okay, you're just making a condition, that's it, okay. Finite.
You can. 1 by.
Okay. For what it got terminated. So it is going like this. Okay, let's everybody try and then. What is the complexity?
N to 10.
Okay, somehow correct.
For me, I think it will never terminate because if the first loop is running, then I is less than n. Okay, so now I is ever decreasing. I mean, I is suppose it is 1, now it's 1 by 2.
Okay.
So it's decreasing. So the condition will never but that when I is less than n, because I mean, if first condition is true, then it is decreasing after that.
Okay. So I made a mistake that I wrote a less.
Okay.
Okay. Now it's greater than. Now what's the complexity?
Okay. Okay. Now I can.
Equation like N log K is
Okay. Let's solve this. I will solve this. So here we are going like this from 1, 1 by 2, 1 by 4, 1 by 8 like this. We are going. So for let's say some 1, 2 to the power, okay, we will like this will got terminated.
Sign should be opposite.
No, for termination this need to be
Greater than. I should be.
okay. Now let's apply. So how we can solve this?
Take log to both sides.
Okay, let's take log on both sides. So if I take log on both sides, it will be like this. Okay. Now log a by b is log a minus log b. So it will be like this.
Log 1 by.
Log 1 minus log b and log 2 to the power k is k log
K log 2.
take k log 2. Okay, then okay. So log 1 is some constant. It's not 0. Log 2 is 1.
Yes.
So I can do a shifting. I can
Log 1 is 0, you can take.
can look like this. So k is on one side, log n minus log 1. So log 1 is some constant. Okay. So what the value of k we are getting here is log n. Just check where you missed. It's very important to understand the part where you missed. So you are correct, but you didn't solve the log actually.
I got log 1 is 0.
I'm not sure. It might be, might not be. So I put it as a constant. If it is 0 also, then it is log n. If it is some constant also, then it will be in that case log n only. Is it correct? Harsh, Swati, and Shuman, Supratik, is it correct?
Yeah, correct.
Yeah.
Okay. So one last problem I want you guys to solve is this. What is the complexity you are observing?
N log n square.
And log n square. And log n log n square.
So log n into log n is log n of whole square.
Yes,
But there is a difference between log square n and log n of whole square. So that is correct. So n into log n is n log n of whole square.
Yes.
Yeah. Correct.
So pretty much this in the practice. So in complexities, we are going to continuously discuss about it. So this is just for give you a visualization. So generally people have a distorted type of visualization of complexities. So this is the proper way. If you observe the number of the elements, how many elements you are dealing with and how many times you are processing them. So it remains a standard among all the things from first day till the last day. Now before moving forward, I want to discuss few things. See, in data structures and algorithm, there are two parts for any problem. First is coming up to a better approach. First, converting that approach into a implementation. That is the second part. So both the part is very, very important. If you feel any discomfort in converting a code to the implementation, it means that you need to do some extra practice. So for that purpose, I have already prepared a list of some basic questions, some very, very basic questions. So you didn't have to put a bit, you don't have to do a very much of brainstorming in doing that problems. In getting the logic, but you have to convert that logic into a code, and very important. First thing. Second thing is, it's for the people who I'm talking for the first time. So I generally give two types of assignments. One is home assignment, one is class assignment. So class assignments are 1 or 2, 3 questions which I want you to do it, okay, and need to be submitted by Thursday of every week, okay. Home assignment is your practice assignment that you can do continuously whenever you get time. So other thing is, I understand we are professionals. We have a very other responsibilities also after the office, but I want at least 1 to 1.5 hours to be spent on TS. Okay, priority is given to class assignments, and other than then the second is the home assignments. For class assignments, whenever the class assignment is submitted to me, see, you have certain set of questions. One is problems. One is we are solving in classroom. One which you will get in home assignment. One which you will get in class assignment. And extra, I have put it for the people who do the class assignments. Okay, I want to distinguish between the people who spend time to do the class assignments. So today also I will give one class assignment. In complexity, this is much, okay, from my side. So today itself I will give one class assignment. So for the people who submitted the class assignments on time, then I will reward them as some set of extra questions, okay, to practice more. Now the other thing is, whatever the class assignment is, I don't want any bookish language. I want your own words, okay. I don't want you to mug up. I want you to understand that part. Okay, so whatever you understand, just write it up. That's okay. 4 lines, 5 lines, pretty much more than enough. Okay? But no bookish language. I want. Class assignments, you have to submit it to me in my mail ID. Okay, and home assignments, it depends on admin how they will take it. Generally, people sometimes put it in drive itself, or it depends on admin how they want to take it in the Google group or something. Okay, but more concern I am about it is the class assignment. They are very, very, very important. Home assignment is for the practice. It doesn't mean that they are not important. They are also important. Okay. Apart from, so how much are you comfortable with the implementation part? How much are you comfortable with the implementation part? Whatever. See, it's your choice. You want to use Python C, CPP, anything you can use. But how much comfortable? I seriously ask this question. Why? Because some people are pretty much comfortable, some people are not. Okay. So what I will do is I am not going beyond this point today. I understand we have not discussed for whole 3 hours, but I want you guys to do some basic practice. Then we will start our discussion. Okay. And in every class, how we are going to do it? We discuss the basic concepts. Then we move to the problem solving part. With every concept, we are going to learn one thing, why we need that particular thing. Because it's very, very important. At any point of time throughout whole 3 months or whatever the discussions we are having, if you are feeling unconvinced with any of the argument, please tell me. Okay, I might be wrong. Okay, like some sign I misplaced. I might be wrong. Okay, it's very important to get convinced in a proper manner. It's not like okay, for the sake of the argument. No. For every topic, if we are using array, why we are using array, that is most important topic. Okay. So because later on, if I ask you to design any data structure, if I give you a problem to design in data structure, I'm not talking about system design, nothing. No. You should be able to think about the different data structure. Which one is used in which circumstances. Okay. Sometimes array is better than linked list. Okay. So there are some ifs and buts. Other thing is, always when we keep a problem, try to understand the problem statement. Ask me any doubts you have. Assumption, if some assumptions you are making. Let's say if I told you that okay, you have given an array and you are assuming that all the elements will be positive, just ask me, I will clarify it. Then think about the approaches, and whatever the valid approaches, we note it down here, and then we'll start discussion over it, and then we code it. And this is going to be happen from day one till last day. There are two things. Again, one is you're practicing on online editors like HackerRank and HackerEarth. So to get familiarized with all the home assignments are from there. Some of the questions from there, here, whatever the in a structure way I like you should practice is there. So you will get a feel of the online editors. I'm talking about the people who are preparing for the interviews. Second part is writing code on paper. Okay, these two experiences are very, very different. Because when you write a code on a paper, you don't have any compiler to check. You have to check through your own. So when we discuss the approaches, if I ask you to write a code on paper, you have to write a code on paper, and you have to think about all the possible cases for a particular problem. There could be any edge case. For example, if I am passing an array, so what if I pass an array of size 0? Might be possible. It should work. So it is very important because Microsoft, first 2 rounds are completely, they look for the corner cases only. In any of the interview, if you go, they will ask you to, first round will be on any editor or something, but there onwards, they are face-to-face round. They will ask you to write the code on pen and paper, and that too production error-free code. Okay, not a single mistake. Okay, so it needs to be a habit. It requires practice, and it's very, very important. So I cover both the aspects so that you will not feel any discomfort in preparing for that. Today, along with this, few days back, I took one discussion session on how to prepare for the interview. What are the important topics and all. I will ask them to share in this YouTube channel also. Just go through them. Anyhow, we are also going to discuss in later classes, but it is for the people who are actively looking for the interview, like within 2 months or 2.5 months. What I suggest is take at least 3 months to have a good grasp on DS and LB, and then float your resume in the market. Okay, and get the interview and start the interviews. Okay, so can we close our discussion here? Okay, I got your WhatsApp group. I can put it the basic questions that right now we bonus switch off. Okay, I will do that by evening. Please, if you are feeling or not feeling, I should suggest you can start with the basic. Okay, important part. It's very important to convert a logic code into a logic into a code. I've seen very good thinkers who have a very best approach, but when it's come to writing an implementation, they are not good. They missed here and there, and that is not good. Okay. Anything you want to discuss with me? Supratik, Harsh, Anshuman, Mona, Swati?
Sir, one question.
Yes.
So I was actually doing that problem number 10 myself, the one that we see on the screen.
Mm-hmm.
So I was getting the answer as log 1 by n. So is that the same as log n?
Yes. So log 1 by n is log 1 minus log n. So
Okay.
negative also we take it as a constant only.
Okay, got it.
Any other doubts you guys have? So please do the basic question set. Okay, it's very important. And I understand that we have professional and personal responsibilities, but to prepare well, we have to put some extra effort, then only we can live. Okay.
For preparing for these companies, you said Hacker Earth or Hacker Rank, some website you said, right?
Mm-hmm.
So you have to practice in those problems on the paper or?
No. So all the home assignments are from the online editor. So
Okay.
they from Hacker Rank, Hacker Earth, Lit Code, practice session of Geek for Geeks, and some here and there also.
Okay. So you are saying to practice more on the paper, pen and paper.
No, I'm asking you to practice on both. So in the class, the people who are online, I will share one website link that is called as Collab Edit, where you can open a document and share the link with me. I can see whatever you are writing the code there. Okay, so I can check there. So it is almost same as pen and paper. When we say pen and paper means online normal notepad also, where you can't have a compiler capabilities, where you have to do by your own only. Okay. So any other doubt? Suprati, Harsh, Swati?
How we will get the class assignments? Where we will get it?
The class assignments, okay. Today's class assignment is here. There I have to create one folder. I will create one. See, this is the earliest batch. So here have the assignment and everything. So here have the complexity assignment as well. So what I want you to do today is you have to go through amortized analysis. This is term. I'm just giving you the term. This is today's class assignment. Amortized analysis. Might be the spelling is wrong. Amortized. See, for any assignment, you can take help from anywhere. Okay, except the coding part. If I ask you to write a code or the improvement, that is not. Amortized analysis, you can, any theoretical kind of topic, you can take help from any reference, understand it first, and write it in your own. Okay, and submit on my mail ID. I will check it. I will give you the feedback there. Okay, that's it. So you have to go through amortized analysis. Today I am getting some problem while creating the folders here. I will check with Anna. I don't think she gave me a full permission here. I will check with her. I will create a same folder like this, assignments and all this. I will have topic-wise assignments like array complexities, and I will do class assignments. Normal assignments also I will put it there. Small assignments. This is Google Drive. So before going home today, just check with the Anna where all the you should have all the accesses. Okay. Okay. Yes, I will put it there.
So online, so they'll send the mail also to us.
Sorry.
For online, to us they'll send mail, right, to the Google Drive links and all.
You just check with Anna. She will share all the links with you.
Okay, sure.
Okay, Anna or Aditya, they are the admins. So regarding any access or something, they have to do. For me also, they only give. Okay. So it's a nice discussion today. I will suggest go home when the recording will upload it. Go through it once more time and start doing the basic questions. So when you are doing the basic question, again think about complexities. Okay, it is a nice practice. Okay, guys.
Yeah. Any books, anything you are
Yeah,
suggesting?
we'll put the references here. So some references I generally put reference book. So I will put it. So I will talk about the references book later. Okay,
Okay.
guys, whatever the reference book I am sharing, please. There's two books. One is very advanced. One is very basic. Okay, so always start with the basic. Once we are completing the discussion, our discussion, complete the basic, then take the advanced one. Okay? Don't jump to the advanced. It is a bit high. Now the basic book have a very good understanding of very small things. Anyhow, we are going to discuss it here. But if you want to go through any book, now the other thing is,
You're providing PDF.
yes, I will. That is in C. I will provide in Java as well. Okay. Uh, what was saying? Yeah, reference book. So whatever the topic we are going through or we have done it, please look into that only. Don't jump it because I want you before we start any topic. I want to start with zero. If you already have some thoughts with any topic, anyhow we will come to that thoughts only, but it will be like a jumble up in your mind. Okay, so it will be not a good thing. So that's what with the doubts also. What we have covered or what we are doing right now, bring me the doubts. I will solve it. Also, after the discussion group, it's for the people. This information is for the people who haven't talked with me. After the sessions, we have 4 tests and the doubt session as well. Okay, if any of the topic got missed or something happens, you can attend it any batch under any trainer anytime. Okay, I generally held a doubt session for all my discussion groups. For example, if I have a doubt session on arrays, I will ask people from all the will come. That is something extra. Whatever the doubts you have, put it in Google group. I will solve it for you. Okay. Okay, guys, it's nice talking to you.
Your mail ID?
Uh, I will share. In WhatsApp, I will share. Okay. Or you can check with the Google Drive. Okay, I will share it. That's a simple thing. Okay.
It's on a Saturday, next session.
Yes. So all are there on 5th and 6th. No? Nobody is waiting.
Or do we need to bring our systems here? No.
90% time no, but 10% if admins wants to do something, then they will ask.
If you want to do the implementation also, then it will be good.
Pen and paper. That's why I told earlier. The pen and paper implementation I want.
But there are companies which ask for us to do it on.
So home assignments are there, no, for that purpose. For that purpose, that's why I kept home assignments, all the online edited links, so that you can have a environment friendlier thing. Okay, here pen and paper.
And if you have doubts on that, as well,
Anything. See, for doubts, anywhere, from anywhere in the universe, you can ask me the doubt. Either implementation, either basics, anything. Language specific also I can solve. Okay, so the only thing is put it in Google group and just tell me you have put it out. I will reply back to on that. If it is not clear, I will sit after the class or in between the class we can solve it. Okay. Okay. So I want a small write-up on Amadeus analysis. Okay, what it is, and it is related to complexities only. We'll discuss in the class, but I want you to look into it. Okay, this helps me to engage you. See, this is my 9th batch. Okay, I have seen people differently. Like they go home, they don't do anything. I want a bit of engagement. Okay, otherwise it's of no use. Seriously, I this is like my 9th batch, so I have already 300 interactions with the person. Okay, thank you guys. I'm ending up meeting here. Yeah.
Thanks a lot.
Thank you. Yeah.
Thank you.